Welcome back, everyone, to day 3 of the Cybersecurity with Python and the Microbit v2.0 workshop. I need to check. Yes, I am screen sharing. Can everybody see my slideshow?
You can see it here.
Excellent. For some reason, there's no green border around it like there normally is. Okay, well, give me a heads up if you end up not being able to see it at some point. All right, so for the chat, thank you for those of you who replied in the chat. We'll go ahead and give you the link to the slides again. There it is. And then, as always, if you can, go ahead and set your view, if you have a single screen, to exit full screen, and then get everything side by side so that you can work and watch what I'm doing simultaneously. Okay, so today we're going to finish off brute force and then experiment with malformed packets. Cyber.org is running an event, so they could not be with us today. So what I have is I'm going to, for this part, play a recording of Dr. Chuck Gardner from the previous installment of this workshop, and occasionally butt into the recording when things have changed a little bit. We'll look at the Parallax Educator resources. This will be the Cyber.org Educator resources. We'll do some Cyberbot robot demos, talk about upcoming workshops. Stephanie, do you have an announcement about that?
Yes, there is still time to sign up for the Cyberbot workshop that is going to be in September. It is a different workshop that I closed or was going to close earlier this week. So please feel free if you have not attended one already, or if you already have a Cyberbot but would like to refresh, by all means, you can join in. Just sign up so we know you're coming.
Yeah, and then put in the notes that you have a Cyberbot of your own already. Okay. And then we'll talk about purchasing tips, questions, answers, and wrap up. Okay, so in brute force attacks, we were here. What we started with was we had a vault application where we used binary values. You were able to click the A button to choose a 0 or a 1. And then after doing that 3 times, each time you hit the B button to go to the next number, and then hitting the B button one more time would send over that code, and then the vault would either give you an access granted signal or an access denied signal, depending on whether you had the right or the wrong pin. After that, we went into how a brute force attack essentially uses a repeating loop, which is something that was covered in the microbit basics. So if we look at this, there are actually 2 nested for loops to go through all the different digit possibilities. And after talking about how it works, there's a neat little randomized vault key application. And this is pretty much some quintessentially weak security. Since we've only got 3 binary digits, you only need to try 8 different combinations to find out what the pin is and get access. So step 1 is doing a decimal pin. And it's really the same thing. It's just that you have a lot more combinations. In this case, we're using values from 0 to 6. And and we're using 3 of those. So to figure out the number of combinations, that's 6 times 6 times 6, which is 6 to the 3rd. We have a typo there, which is 216 combinations. Stephanie, if you could email me about that, I'd appreciate it. I'll copy in the link into the meeting. Now, since this is so similar to the binary one, I'm just going to gloss over it and say, hey, we now have more combinations. Instead of 8, there's another step in making things more secure, upping it to 216 combinations. Obviously, that's still not ideal, but I'll get back around to that. Now, the one I'd like you to try next is looking at how brute force could be applied to our Caesar cipher keys. And so let's see, where is the script for this? Here it is. And I apologize, some things where I wasn't expecting it to be. Let's see, radio receive. Okay, so this is our receiver. And this is our sender, great. And then in addition to that, we need okay. I think then that what we're doing here, we need to start the share something personal encrypted application first. There it is. Okay, so what we're going to do is transmit with 1 microbit. So I'll share you the transmitter. We might as well do the transmitter and receiver and just make sure that everything is working. So for that, we'll need to go and plug in our microbits. Okay, so mine are plugged in, then I'll need to connect mine. So 3 dots next to send a microbit, select connect, pick 1 for your first tab, and then in your second python.microbit.editor tab, make sure to pick the other microbit. And then I'll give you guys the web page and then the scripts themselves if they fit in the chat. So here is the transmitter for share something personal. And then here is the receiver. So we'll need to put both of those into our microbits. And then load each microbit. So now we have the encrypted sending and receiving microbit modules matching up. And I believe that we can even take a look at what it's sending encrypted. That's the left microbit. And then what it's receiving encrypted, that's the right microbit. It shows both the encrypted and unencrypted versions of the text that it's receiving, and then using to make the different emojis on its LED matrix display. So let's make sure that we can get some thumbs up on if you've got that running. So go ahead and give me a thumbs up. Thank you, Donovan, Mike, John, Elaine. Oh, thank you, Isaiah. And again, thank you, Nelson. And again, it's really easy to hit the reactions button. You can just kind of move the mouse around above your above the presentation. The control bar should appear at the bottom of Zoom, and then there's a reactions button that you can use to send a thumbs up. Thank you, Carolee. Good job. I looked away. Thank you, Alex. All right, this is looking pretty good. Always feel free to unmute and ask for a little extra time if you need it. Okay, now what we're going to do is change our intended receiver to one that's trying to crack the key for this communication. And so what's going to happen is that it's going to grab some data and then try all the different keys. There are 26 of them for a Caesar cipher. Again, it's a nice weak cipher, so it's a manageable number that we can actually see in our terminal. And so here we go. I'll go ahead and paste this over. So again, load this into your receiver, the microbit that is, okay, so we have, you'll want to find, have serial open in both. We don't want to load it into the send microbit. We want to load it into this receive microbit here. Okay, let me paste it to you all. And the message is too long. I'm going to paste you this. Oh, darn it. Okay. Sorry, folks. I had a little bit of a senior moment here. All this transmitter script is doing differently is it's picking a random unknown sender script. So what you can do is you can load this sender script if you want it. It's nice because you'll get a random key as opposed to the one we were previously using. And then this receiver script, when you run it, I'll show you what to do. So here is the page with both scripts. Now, alternatively, you can leave your sender script running. That's fine too. The main thing is that we want to get the, I think just to go through the whole activity, I'll copy over this modified sender script. But again, all it does is it picks a random Caesar cipher key, a number between 0 and, or probably 1 and 26, 25. Okay, so I'll put this one in my sender and run it. And then put the receive script in the other microbit and run it. And then I'll show you on camera what you'll see. Okay, so once you've got this going, we have okay, this is interesting. Send to microbit. Oh, I made a 6-second delay. If you feel like your microbit is stuck, it's because the delay for each face is longer. And then on this end, when you run it, all you have to do is drag that separator bar up and down, and then go to the bottom. And if you just scroll wheel up or run the scroll bar up a little bit, then the scroll bar itself will stop moving, and you can take a look at one of the brute force attacks. And all you have to do with these 26 or pardon me, 25 different ciphers is look for an intelligible word. And so it looks like the key that they're currently using, I have it highlighted on my screen, is angry, the number 13. And so that's an example of grabbing a key out of a communication stream using brute force. Let me know when you've got it and have figured out your random key. And in fact, I'm curious how random the microbits random is. Could everybody type the key that you figured out into the chat? Let's see what everybody's getting. Because usually these are pseudo-random keys, and I don't remember if I went through any extra effort to make the key more random. You can do things like take sensor measurements and use those to figure the key. Okay, so I have a key of oh, good. Okay, so Mike has a key of 6, and Carol, VDG is not a key.
We have a STAD here also, which I'm assuming is lack of success and not a key.
Well, Carolee, did you get it? Or Carolee found sad. What is the key that corresponds to sad? I see 2 6s. Oh, good. Elaine says her key is 15. My key was 13. Yeah, so we're getting -23. This is cool. So at 19 from John, 23 from Donovan.
If we reflash the send program, would that probably rekey it?
I'm hoping so. I'm going to try that myself. I'm going to reflash both the receiver and sender program. See how, because for example, if you're doing this in old standard C, it's pseudo random, and so it'll be the same value each time. But the microbit may have added a little smarts. Let's see what I get now. Okay, I'm looking for sad. There it is. Yeah, so I'm at 5 this time. Or -5 rather. 3, 22 after reflash, looking good. -2. Okay, cool. So this is truly random. That's great. And so here is an example again for the students to see how something that is encrypted can be intercepted and brute force attacked. And to defend against it, usually the main idea is to strengthen your cipher. The stronger the encryption, the safer your data. And so going back to brute force attacks. So there are several different concepts that are introduced here. The first is, unlike the Caesar cipher, which just has 25 keys, and also there was our vault, which the decimal had eight possible pins, and then I think it was 216. It was 6 to the third, whatever that comes out to, possible pins with the decimal version. A custom cryptobit, that being, if you take A through Z and then substitute one unique letter in the alphabet for each letter. So in this case, A is the letter P, B is the letter T, and so on. So now you have this really long key, and the number of combinations possible is 26 factorial. And it does a little blurb about how to calculate factorials as well.
I have a question that was a few replies back from
Okay.
Isaiah. How much does this process differ from Windows and Linux? I don't know in what context, but.
Well, yeah, it really depends on this is starting with classical stuff that isn't used anymore because it's nice and weak, so the students can actually experience actually cracking a code. If you're doing Windows and Linux, you may be dealing with like AES 256-bit encryption, and that takes a long time to encrypt, and and I mentioned earlier on that there are libraries that are used to do encryption and decryption. And there is more on that. So you will actually see coming up soon during this session, a brute force attack that is performed on hashes of machine passwords. And so that's coming up after 4 o'clock. And so that may also be that'll be kind of the real world example. But the microbit networks are nice because they don't require any special IT involvement. But the cyber range that cyber.org has and their lessons also is kind of a neat thing. You go to a web page, and through that web page you can create various virtual machines. And I probably shouldn't be giving so much away. I'll just let's see. I asked because going forward I want to do this from my Linux computer. So are we talking about how different the microbit is, or how different doing the scripts in Python are, or let's see, how much does this process?
Just to clarify, our curriculum will work the same on Mac, Linux, or Windows, and the programs in the microbit, once you download them on the microbit, they work the same regardless of. I think that's what he asking, maybe, that he will use Linux machines to program the microbit, then to follow the curriculum.
And that might be the case. And Ari, could you mention the Chromium browser in the tests you did?
Yes, I tested it in Raspberry Pis only in Linux, and it works just fine. The same, I ran the same code, the same curriculum.
Yeah, and the main thing is that Chromium does not necessarily come with Linux stock. You have to install it, but after you've installed a Chromium browser, then it has the features that Chrome uses for the cybersecurity lessons, and that's Web USB and Web Serial.
Andy, have a question for you too.
Oh yes, who is this?
This is Mike Schaefer.
Oh, Mike.
It sounds like if we were not focusing on the programming aspect, if we were just going through the motions of the simulation with the microbits, Sounds like the best way to do that might be put the hex files on a thumb drive, just have the kids drag them over on separate
Yes,
machines.
yes, definitely. That's a really good idea. Yeah.
Okay.
Yeah, and that speeds it up, and it takes if you have hex files and you're in a position to say, okay, well, we're going to run this hex file. We're not really looking, we're really focusing on the cybersecurity aspect of this and not on the learning to make Python scripts aspect of this. So when you run this, here's what to do, and here's what happened, and let's talk about that as it pertains to cybersecurity. And then, yeah, you could share the pre-written hex files with them, and that would go really well.
The editors we're using, I think those we can save them as the hex file, right?
Oh, yeah. As a matter of fact, okay, so when I hit save, okay, untitled project, fine. Notice, I don't know if I can zoom on. Oh, I'd better just open a Windows Explorer.
Okay, I just did it. Yeah, it's hex.
Yeah, it is hex. So it appears in your downloads. Downloads. And then here is the one I just downloaded. And yes, see how it says untitled project.hex. So yes, yeah, saving the hex files. And then when you open them, there's two ways to open. One way is really easy. Bear with me. Okay, so here's one way is to hit open, and then it'll take you to your downloads, and you can browse to wherever the file is stored. You can you can use your file browser to look for whatever folder or flash drive they're stored on. Now, when you want to open a file, what you can do is simply drag and drop it. For most computers, you can drag and drop it right onto the editor, and it opens the file. Excellent question. Thank you. Let's see. So we were talking about stronger keys. So here's one version of a stronger key. However, you can probably break it simply by looking at the number of characters and inferring what those characters might be. So because there's extra information, it's not really just, hackers are not really just limited to trying this seemingly infinite number of combinations. Another way to strengthen apps is to add a time limit so that the brute force attack has to wait a little while before it gets to try again. So here's one that you can try on a single microbit. Just run it and go, and then open the serial console. Paste. There we go. Okay, so it gave me a web USB error, but when I tried to program it again, it looks like it recovered. So the correct number is 324. And if I try this 3 times and fail, now I can't try again for another hour. And you could make it 5 minutes. And regardless, it's another technique that is used to slow down brute force attacks. And if I run it again and then do 1 wrong and 1 right, okay, 324, and access is granted, whereas the rest of the time it was denied. And so that that's kind of a look at the different, I'll talk about one more thing with this, and that is the strengthening previous applications. So the student is challenged to go in to share something personal, encrypted, and use something like the scrambled alphabet cipher. And then also for the Cyberbot, there's keyboard control with a, there's a keyboard controlled version of the Cyberbot robot where it can go over the radio. And so that could be intercepted too during a robotics contest. And so here we have an example of an alphabet of all the characters that are used in a custom cryptobit, which is ends up being 19 factorial for the number of combinations, which is still pretty good. Moving on to malformed packets, and feel free to jump in with any additional questions you might have, either over the chat or by self-unmuting. Malformed packets are most frequently used with distributed denial of service attacks, DDoS attacks, because it adds processing load to the server that's being attacked by a bunch of bots that are giving it information that it's not designed to respond to. And so this is a demonstration of malformed packet attacks. And there are 3 different takes on it. 2 are microbit only, and then the third is the Cyberbot. The countdown timer that we've done a couple of different times has on okay, here's the countdown timer. This countdown timer has a little extra option that an attacker might use of sending the value -1 and then instead of a positive count in seconds, using a negative count or the value -1 will send a non-number, and the microbit, if exception handling is not in place, the microbit will choke on that. So let's try this page. And what I want you to do is run both the sender and receiver. And first of all, try the countdown with normal positive numbers like 3 or 5 or 7 or something like that. And then after that, try -1 and see what happens to the receiver microbit. And I'm going to go ahead and do that also. So here is the countdown transmitter, and I'll paste that into one tab and send it to the microbit. And then we'll go down and get the receiver and paste that into the other microbit. Run that. Okay, and then I'll put these side by side here. Okay, and so I'll just start mine at 3 and make the message Happy New Year. Okay, so we know it's working now, and then I'll try -1. And let's see here. Okay, so notice that there's basically we see an error message. And then looking at the microbit, it's displaying an error message. And after this, it's essentially crashed. So you can try to send it another countdown, but it couldn't recover from that attack because the malformed packet, it did not have any exception handling. And so if I type in another set of information, notice the other microbit, the receiver microbit, does not respond. And now you can get the receiver microbit to come back. You can hit these 3 dots on the right and then select Control D to reset. And then it'll be ready to go again. Alternatively, you can also press and release the reset button underneath the microbit right next to the USB cable right there. So pressing and releasing that does the same thing. And then the sender and receiver tests are just the step-by-step instructions for how to prove to yourself that this attack succeeded from one microbit to another. And then there's a how it works section. And there's, let's see, I'm sorry, try this. There's a try this where we add exception handling. And so it's essentially saying here to add pretty much the somewhat of the minimum. It's saying take this existing code, indent it by 1, and then add try : up above. Then take the then add this line to see the exception, and then add finally where it will print whatever the message is regardless. And so I'll make those modifications real quick and then paste you the modified script. Okay. While value is greater than equal to 0. So that's where it chokes. Is in trying to count down, because it can't count down to a non-number. Remember, it sent a text message instead of a text that represents a decimal value. So I'm going to indent that by 1, then right above it, add try and a colon. Do I need to capitalize that? No. Had a little capitalization fail there. And then finally, print message and print an empty line. All right, let me make sure this works before sending it to you. Show serial. Go back to the all right, so I'll just send both of these to the microbit, and then okay, so I'll send it to. Okay, so we've still got. So it's still working there, and then if I send -1. So it says there was an exception, but is it stopped in its tracks? Did I crash the server, so to speak? Let's see. No, it's still working. All right, so the only thing I don't like is that we're seeing that message twice, but maybe that doesn't matter. I'll just go ahead and send it to you as is. So check your text message for the modified receiver script. Try that out. And let me know if you were able to remedy the vulnerability to a malformed packet using the modified script. And again, that's just the modified receiver script. You can use the same transmitter script, use normal positive countdown values to test it to make sure it works normally. And then also, oh, and I see actually, yeah, line 41, I should have deleted these two guys, or really indented them and put them before finally. I'll go ahead and just paste the corrected script in. Can you get rid of the last two prints? Yes, Eric, I can. There we go. Yes, you can get rid of the last two prints alternatively to pasting in my modified script. And then if you could go ahead and give me a thumbs up when you've tested it, if it works. Yeah. Well, great minds think alike. If I may be so self-congratulatory there. Okay, Eric, thank you. Looking good. All right, Carol, good job. Good job, Mike. See, you guys are all working on this one. That's Robert. Excellent. John, thank you. Carol Lee, good job. Donovan, excellent. Nelson, perfect. All right, so here's another fun one. It's malformed packets. And by the way, this is just, we've been looking at chapters from the entire online textbook here. Here is sharing something personal, but it's kind of, I think it's a little bit cooler of an application. It's also a little bit longer of an application. This one goes into both your microbit modules. Let me make sure it goes through the, yes, it does. Okay. So this one you can put in both microbit modules. I just texted it to y'all. And this one is set for sending something using the buttons. And what you can do is use the other microbit. This is fully bidirectional. You can use the A button of either microbit to do anything but the skull here. So I would recommend the check mark or the X or the heart. So here, I'll send a heart. Great, it works. And then I can send something back by pressing the A button until I choose I'll send a check mark back with the B button. And sorry, I was covering up the so there's the X going through. Here's a heart going the other direction. And then watch what happens when you try the skull. Frowny face, exception. And you can probably also see in your terminal that there was an exception on line 33. And if we look at line 33, we find out that this is where we're trying to deal with an emoji, but we may not have received an emoji. And just going to summarize what's talked about in the text. Basically, image skull is one of the options. And when you send, it just has a little extra code here, little stub that says, instead of sending image.yes or image.no or image.heart, what it does instead is send something that's not an image at all. It just sends a string of text that we arbitrarily chose to be malformed packet. And when that goes across, then when it gets to line 33 and it tries to parse that, it does not, it does not succeed, and an exception occurs. As with the previous one, there's instructions on testing. Then there's a try this to prevent it from freezing. And well, there's first a how it works, and then a try this. And again, the try this is indented, or is basically putting the existing script into try and except. There's no finally in this case. Let me see if I can make that change and get this to you fast enough. Okay, so it's only the radio receiver that we're worried about. And then let's see here.
Question, why did my serial bar turn red?
The serial bar turned red to tell you that an exception occurred. And it should have come with a message too. Like I'll restart my microbit and then send a skull. Okay, so here's the skull. And when I send it, we get the frowny face. And I think that I made a mistake by not loading the script and showing the serial. Now, when I send the skull, it turns red, and you also see the message of an exception that occurred.
Donovan notes the skull breaks the receiver if it gets sent and have to reset the receiver.
Yes, and so what you can do is you can do that by pressing the reset button that's underneath the microbit next to the USB connector, or you can click the 3 dots in the terminal and select Control-D to reset. It might wait until after it's displaying the message. I don't remember for sure on the soft reset, but I believe now it's ready. If I go to a different emoji, send it, Yeah, it's working again. And oh yes, so we're going to cheat and open up the original document here. Let's see here. That way I can just grab the solution for you. Exception handling primer. Bear with me, I'm on my way to, this is the source document. These things get written in sometimes Microsoft Word and sometimes Google Docs, and this is also where the solutions are kept. And I'm looking for range of 6 maybe would get me there. Oh boy, well, I apologize for this, everyone. Let me just update the script. Okay. Oh, this one takes a lot of updating. I really should just grab the solution. Okay, prevent freezing. I'm gonna search for prevent. Oh, okay. I opened the wrong source document. Let's see here, Mel. I opened exception handling. Okay, so here's the instructor's copy of exception handling. And then we want to go to the prevent freezing. I wonder if the section was renamed. Let's try skull. Almost there. Again, I apologize for the delay. Okay, so here is, I believe, the solution. And just my luck, it'll probably be too long to paste into the, yep, it's too long. Okay, I'm gonna have to paste this one in 2 halves. Okay, so we'll do. Okay, so here is the first half. And again, this is for your for both scripts. So that's the first half. I'd recommend pasting it into one editor. And I'll do that too. And then paste it once you've got the whole thing built up. Then paste it into the other editor. Okay, so we're down to radio. Send packet. So yeah, I have to continue from here. Here's the second half. And then paste that below the first and make sure to start it at all the way to the left. Okay. Did I mess everybody up? I'm going to copy this from the chat to make sure. So hit the carriage return a couple times between the first and the second. Yeah, I see you're getting an error. Just a sec. Copy. Paste.
It took figuring out the indentation between the two halves, but it works fine when I copied and pasted them together.
Okay. Let's see here. It looks like,
Indent line 27.
okay,
There you go.
there we go. Okay. I think maybe I better just give you guys the teacher's doc link. Make sure everybody can get it. It's on, you'll see pages as you scroll up and down, and it's on page 30. It starts on page 32 and goes through to 33. And file, share. Copy link. Okay, here's a link to the document. You can just grab it right out of there if you're having trouble with the two halves of code. And again, that's on page 33. Oh, I see lots of people entering the document. Cool. Welcome, everyone. This is kind of segueing into the educator resource portion of the presentation. Here's a quick peek at what we make available. And then essentially, I believe that if you put them into if you put them into both microbits, there's still the little stub that sends the malformed packet. So, so yeah, you can run both of these. And now, if there's an exception on the receiver microbit, it's going to briefly flash a sad face several times just to let you know it got a bad message. But otherwise, instead of being stuck in its tracks and not receiving any more emoji from the transmitter, it will go back and start listening again. So if I send the correct emoji, anything that doesn't have a malformed packet, everything's still working fine, but I just sent the skull emoji, and it blinks as frowny face and then goes back to whatever it displayed previously. Plus it's showing that it's displaying here in the terminal that we received a malformed packet.
Got a really cool for that from Alex Martinez.
All right, thank you. Yeah, I thought this one would be a lot of fun. And with that, what I'd like you all to do is just finish that up and then take a break and meet us back at 10 past the hour.
I will also pause the recording during the break in case anyone would like to ask questions without being recorded.
Okay, welcome back, everyone. I just wanted to show you one last thing from from the malformed packets lesson. And one thing that I forgot to do is I'm going to be using the Cyberbot robot for this one. And so I need to add a file to my project. And so I'm going to go searching for that file here. Let's see if I have it in my downloads. Okay. So with the Cyberbot robot, there's a little additional file that has to be added. Let's see if I can find any Cyberbot code in my downloads. Ah, hey, there's the Cyberbot MicroPython files. Okay. So basically you need to go to projects and then open an additional file for your project, or you can go and I didn't want to replace my main code. Let's see if we open a file and then go to Cyberbot MicroPython. Let me see if I can find that file again. Add module cyberbot.py. I made the mistake of trying to copy it over from within a zip, and that's why it didn't do what it was supposed to. Okay, so now I have cyberbot.py added to my project. You can actually look at the code by it takes a bit because they don't want you to willy-nilly edit some of the modules that you might add to a project that are made in addition to your main code, because doing so might cause the module not to work properly. This is the Cyberbot module. I just added it to my project, and now when I send it to the microbit, it should load into my Cyberbot. And then I also already loaded a script into the a microbit. And so if we okay. So here I have a Cyberbot robot, and here I have a transmitting microbit. And I'll go ahead and turn my Cyberbot robot on. And then the transmitting microbit, I'll set the left speed equal to 40 and the right speed equal to 40, and then the runtime equal to 2000. Oops. Let's try that again. 40, well, 20, 20, 2000, enter. And then there it goes for 2 seconds. So it went very slowly for 2 seconds. And I could also send the Cyberbot robot negative values, -20, -20, and for another 2 seconds. And then there it backs up. And that's great. But what if I instead try to go forward again, but I send it -1 as the number of milliseconds to run? It is now stopped in its tracks and turning infinitely. Not really a favorable outcome. And that's because of the, if we look over in the Cyberbot's terminal, of course, it threw an exception. And it's because it did not like the little trick that we played on it, which was to send it text instead of a number value for the amount of time. And so what I'll do is show you how to fix that. Malformed packets and the keyboard controlled Cyberbot. So here is the transmitter and receiver. And since you don't have a Cyberbot, I won't have you do that. I just wanted to show you it as an example. We've been focusing on the microbit because that's what you have, are 2 microbits, but there are Cyberbot robot examples salted in throughout all the cybersecurity material. And so again, adding exception handling is going to fix the problem. And I am now in the teacher's guide, and terminal controlled bot wireless exception handling is the script I need to fix it. And what we have for the students is a picture of it so that we can get them to put their hands on the keyboard and get it running on their own and troubleshoot any mistakes they might have made. Okay, so if I send this modified version to the microbit and then go back and okay, so left speed 20, right speed 20. Hopefully I put those in the right microbits. I was in such a hurry that I might have done it wrong. Enter. Oh, I had the bot power turned off because it was turning in place. Okay, so the application works. And then if I send it a malformed packet by 20 and 20 and -1, it flashes a frowny face, but recovers again because we used exception handling. So now if I try to go forward again, it does. And this is great, especially in robotics contests, for students to see how if they harden their application against attack, they can make it through. If we have some attackers on the sidelines, they can make it a lot better than another team that has not added exception handling. And so that is, that's all of, that's what we have published currently for attacks and defenses. And now I just wanted to show you a little bit about cyber.org's resources. And for that, we're going to play portions of Chuck Gardner's presentation that I recorded. And I'm going to stop and jump in and also skip a couple things that we've already looked at. So here we go. Welcome back, everyone. Today we have with us Dr. Chuck Gardner, who has worn quite a number of hats at cyber.org and is currently the Senior Director of Government and Nonprofit Engagement. Did I get that right, Chuck?
You sure did.
Okay, that's a mouthful. And Chuck is going to be showing. Video is not showing. Oh, it is. Never mind. Okay, good. Showing us some really neat stuff that's available to all of you as United States teachers that cyber.org has for you at no charge. And with that, take it away, Chuck.
Thanks, Andy. My friends call me Sir Dogan P,
Huh?
Senior Director for Government and Nonprofit Engagement. If
Oh.
you turn into an acronym, as we do with all government funding, it's Sir Dogan P. So you heard it here
Nice.
first. Great. So if I may.
Okay, so I just got a message from Stephanie. The video is small in the corner instead of the focus. Okay, so what if I stop? No, it seems like, well, yeah, are you sure about that, Stephanie? What we want to see is still the slides, and then Chuck, just kind of a small thumbnail. That
Oh,
is.
okay. If Chuck is supposed to be a thumbnail, then you're good.
Oh, good. Okay.
Okay.
Yes, Elaine, that is the way it was recorded. This is the first time we've tried this during one of our Zoom seminars, so pardon the bumpy ride. Let's keep going.
Capitalize on the screen share.
Oh, yes. Let
do have
me
some
exit
tabs to work
mine.
through.
There we go.
Thank you. And Des, I want to go to my Chrome. All right, we're live. Thanks. These are great sessions that you guys have the opportunity to work with Andy and Stephanie and Ari. And I mean, it's just really great stuff to see the folks who are writing the content from the Parallax perspective. While I can't represent that perspective from cyber.org, there was a time when I wrote curriculum, and as Andy mentioned, cyber literacy was my bag back in the day. So that was a lot of fun working with you guys and developing that content. So we'll see a little bit of that today, but I've got a couple tabs across the top here. It's my intent to work from left to right. I want to show you kind of where we are and where you can find that information at any time. We're going to take a look at my lights just changed, our dashboard of content, what you can get access to on our Canvas learning management system. I'm going to take a look at the cyber range, as Andy promised. I got a quick activity set up there. And then we're going to take a look at those two more tabs that'll round out our 25 minutes together. So cyber.org, our name is our address. Head to cyber.org at any time to get to this homepage. And from here, you can get to everywhere you need. So the first thing I'm going to point out is to sign up for curriculum. You can click this link, which will take you to a quick form just to kind of validate that you're, as Andy mentioned, an educator in the US, that you're involved in K-12 and not higher ed. So we're funded through a grant from the Cybersecurity and Infrastructure Security Agency, or CISA, and that's this icon down at the bottom of our page. We've been operating under CISA funding since 2012. This is our 10th year. We've been doing this work in Northwest Louisiana since about 2008 under our parent organization named the Cyber Innovation Center.
Sorry for stopping and butting in. I will do that several times. For this one, I just wanted to mention that every single link Chuck went to, I put in the slideshow that you have access to. Some of those you have to have already signed up to cyber.org, but just don't worry, the links will be there and they're in the same order that they're presented in case you want to get back to anything that he's demonstrating on the cyber.org site.
So this work's been ongoing for some time, and at this point, we've now got a full library of content that we provide to teachers across the country. Andy would call it these days prepaid because it is government funded. You pay your taxes, you get access to the content.
Okay,
So it's
got
prepaid.
it.
So the content's free for everyone, and that includes curriculum, professional development, and the cyber range, which we'll take a look at in just a second. For you, depending on where you are, I would love if you're back with us at this point, just drop into the chat real quick. Two things, a number telling me.
And you don't need to put any of this into the chat. We've already got your stats, so from your signups.
What roughly grades you teach, and letters indicating where you are. State abbreviation would be awesome. So let me know where you are and what you're teaching in a one-line chat response, if there it goes. Speaking of our impact, well, we're all recovering educators. We have a great team of former classroom teachers, including Lori Salva, who's now the director of cyber.org, a great team of directors, including Joe McAdam, who writes the cybersecurity content, who taught this robotics content on the Bobot platform in the classroom. And then the rest of us, just a really dynamic team of former educators and folks who are leading this professional development. But what I wanted to show was our impact, because if you're in obviously a state across the country, there it is. There's some impact that cyber.org has already, because we have 30,000 educators who have access to the content, all 50 states, 4 US territories. So there's teachers from coast to coast. It's a great network that you're going to join if you sign up for access to the content. But the first response I saw, I think, was Illinois. And so let me just pop up Illinois here real quick. If we take a look at Illinois, there's 670 teachers who have access to the content, 400 who have been through professional development. But this document gives us kind of a closer look at the impact by county across the state, some partnerships, some relationships of note that are happening there, some conferences that we've presented at. And we've got this for every state, including the value of technology. And that's one of the things I'm going to hit at in just a second. Our DHS funding allows us not just to give away content and professional development, but we also put resources in classrooms to the tune of $45,000 across Illinois in the last couple of years. And then this number, which is great, the number of jobs available in the cybersecurity sector. If you haven't been to cyberseek.org, it's a website, 26,000 jobs currently in the state of Illinois that exist in the cybersecurity sector, out of the 700,000 plus across the country. Cyberseek.org should be something that you're showing students if you're interested in talking about workforce career awareness in the cyber sector. So when you go up here and you request access to the content in the sign-up form, that's going to take you to request access to our Canvas learning management system. So we host all of our content on Canvas. Me and my team, we're all the teachers, quote, air quotes here, right? We're the teachers on Canvas. You all, the educators across the country, are the students on Canvas. So you're going to get a student account. And that just means that we can demo content before we make it live. We can pre-publish and tweak and stuff. As students, you only see once we're ready to debut that content. The other thing is, when you get access to Canvas, your icons won't be in the same order. You can drag and drop and resort your stuff. I put the stuff that I use at the top of the page and the stuff that I don't traditionally go to down at the bottom. So you're going to get access to Canvas, and this is the teacher account. We generally don't give access to students because this teacher account includes study guides, tests, answers, solution keys, worksheet solutions. So we want to make sure that this content stays at the control of the teacher, and then you download and share whatever it is you want to share through your learning management system. So one of the things that Andy mentioned was the microbit content that we've got in our library, and that falls in this coding fundamentals course. So wherever it falls in your library, if you click on coding fundamentals, you're going to see 2 main tabs besides the home button. You're going to see make code and Python. So as you've learned over these 3 days, Microbit is a really versatile, flexible platform that can follow a student from elementary through high school. In elementary and middle school, they're going to use a drag and drop style programming language, which is done in this make code editor by Microsoft. And then once they advance through that and they're learning in middle school and high school, we've got Python content. And each of these is a link to a set of lessons and activities that are going to utilize the microbit and all of those sensors and components on the microbit. So a lot of this you may have seen with the workshops with Andy and with Parallax. For example, we talk about customizing images and making some animation, but then we've got down here some kind of more advanced topics, buttons and conditionals, which you took a look at over the last couple of days, how to use the radio feature, how to use that magnetometer and turn the microbit into a compass. But then we've got some more advanced concepts. I'm not sure, Andy, if you guys talked about how to create a voltmeter out of the microbit, but we've got that component there, turning the LEDs into a light sensor, and then making some games. And you see there's a teacher guide, which includes a PowerPoint presentation. And then there's a student document, which doesn't give away all the answers, right? It's something for students to work through. And at the bottom of each of these pages, we've got some cybersecurity content. So for elementary and middle school or drag and drop style programmers, We've got some cybersecurity content that includes working with some ciphers like Pigpen or a Shift cipher, which you were talking about today, and a Visionaire cipher, maybe some Morse code encryption, encoding. And finally, there's an Enigma activity, which you can use the microbit to build a version of our Pringles can paper and pencil Enigma. And similar lessons exist in the Python. So if I click on Python, we see a lot of the same activities up top. There's hello world and animation and variables and images, and there's the magnetometer and compasses. And then there's some really great cybersecurity content at the bottom, which some of you've seen already. You talked already about, radio basics and using a dictionary and sending packets wirelessly. But then we go into replay attacks, and there's that brute force attack. Now, why are we showing the same content that Parallax has? I love Parallax from a student-led perspective. A teacher can direct a student on how to get to a certain activity, but you can turn them loose on the Parallax page, and they can start on step one, and they can work through all of that content, even to the do now, the try your own activities. Our content is more designed for that sage on the stage, right? This is kind of teacher-led content. We've got a PowerPoint presentation and notes for the teacher to lead students through a lot of the same learning that's happening on the learn.parallax.com site. So similar content, kind of two different approaches to the instruction. But we all huddled up in the same place a couple of years ago now. I think this was just before COVID, wasn't it, when we got together and did all this content development?
I think it was, yes.
Yeah, we weren't wearing masks. So, so if you're interested in using more microbit stuff, come over to Coding Fundamentals in cyber.org's LMS and take a look at microbit, make code in Python. And the last thing I'll say before I move on to another course is, when you see things like Hello World, programming with displays, buttons and conditionals, compass and comparisons, I should go over to make code. I see Hello World, buttons and conditional. Oh, wait, here's it. Compass and comparisons, buttons and conditionals, and variables and images. What I like about this is students can grow up with the same activities. They can practice with block, and then they can kind of, graduate right to that text-based Python programming language. They can see the exact same activity in two different programming styles. And what I like about leading into text-based programming is that it really prepares a student for success in a lot of the more higher rigor courses. Once you mount that microbit onto the Cyberbot, it's all Python. It's all text-based all the time. Once we get into cybersecurity, we start learning Linux. It's all text-based all the time. So getting a student to go from this block style drag and drop programming into Python, I think, is a really great opportunity to let them kind of see the rigor, right, as it increases and work through lesson by lesson. The content that we have for the Cyberbot is housed in Cyber Literacy and Cyber Literacy 2. They should probably be next to each other, so I'll move that over. Cyber Literacy was the course that I wrote while I was teaching the Bobot content down in New Orleans, and we've ported it over now to include all three Bo platforms from Parallax, including the Bobot, the ShieldBot with Arduino, and the Cyberbot. So you'll see the same robotics lessons, similar robotics lessons in each of these courses. It's basically up to the teacher to pick your programming language. Bobot is programmed in BASIC, Arduino is programmed in Arduino version of C, and Cyberbot in Python, depending on the language. That's the platform you work with. Everything else in these courses are the same. So again, you don't have to go to all the electricities. They're all the same. Same with liberal arts. But what this course does is it kind of provides this really overarching view of cyber. In the liberal arts content, students are going to work through conversations and research projects and discussions on what it means to be a responsible cyber citizen. They're going to have conversations on Fourth Amendment's rights to search and seizure in CyberLit 2. And then in electricity, they're going to build simple circuits using a breadboard and components from Parallax. And then they're going to put those to the test in the robotics session. Cyber Literacy 2 takes those builds to the next level, and we add more sensors and more components, and students work towards becoming essentially a systems engineer, where they're going to combine multiple circuits on a single Cyberbot and programming it with Python. So CyberLit 1, CyberLit 2, good opportunity to bring some electrical engineering, mechanical engineering into a cyber themed course. I'm going to round out with cybersecurity, but before I get there, Cyber Society is our low, no tech opportunity to have students working in small groups to do research projects on all things current events cyber and also historical, because we have conversations on things like cyber communities and business, cyber law and cyber terrorism and politics. And in the community section, for example, they're going all the way back to Aristotle to learn about what it means to be a friend. And then they're bringing that conversation forward into today's society to talk about what it means to have a digital friend and quantity versus quality, right? It doesn't make sense to have thousands of digital friends if you have no idea who they are. So let's talk about quality of friendship versus quantity of friendship. And those are the things that we're doing in Cyber Society. And the last thing I'll mention as I kind of segue into the cyber range is our cybersecurity course. This is our advanced technical cybersecurity course where we're using a cyber range, which is a virtual, safe, secure environment to practice cybersecurity. That page isn't loading. I'm still here, right, Andy?
Yes, you are. It just loaded.
Okay. We're using a safe, secure virtual environment to practice cybersecurity so that students can be prepared for success on the Security Plus exam from CompTIA. As an entry-level credential, many employers of cybersecurity personnel across the country are going to accept that for folks who are new to the industry. We did a study across I-20, which is covers across northern Louisiana, all the cyber industries and what credentials are most in need for your jobs. Security Plus came up across far and above any other credential as the one most in demand. And if you go to Glassdoor, which is a glassdoor.com or CyberSeek, just to take a look at what opportunities are out there, Security Plus is again, far and above the #1 credential most in demand for entry-level jobs across the country. So here's our cybersecurity course. It's chock full of labs and case studies for students to learn and talk and do research around cybersecurity. It's also got teacher notes and presentations. It's got student documents, and it's full of quizzes based on every lesson, every component of the Security Plus exam that's got content for it. So Security Plus is made up of 5 objectives. Each objective has a couple dozen terms. We've broken it down into each term and provided a lesson for those terms. So we've got a lot of content here, a lot of labs, a lot of case studies, and you know, you're worried about how you're going to present this content. We've got professional development, just like Parallax says, which I'll show you what that looks like in just a second. Let's get to the range. So in chemistry class, right, you have to practice in a safe, secure environment. You know, what happens when you mix hydrochloric acid and some other material. You know, you don't want to do this in an English classroom or, God forbid, in the kitchen at home, right? Because you may not have the materials that would be required to safely protect against some kind of dangerous event. A cyber range is no different. It's where we practice malicious attacks in a safe, secure sandbox environment. We don't have to worry about, well, you should, right? But you don't have to worry about impacting the district's network, because this environment that I'm in here is hosted on the AWS cloud. We've developed this environment. We've put security parameters in place so that students can only launch, right, air quotes here, we can only launch attacks between these networked environments. So if I go to my dashboard as a teacher within the cyber range, this is the class that I fired up. So I call it my live demo. There's 4 students and me. We all have access to a Kali Linux machine and a Windows machine. I've booted them in this virtual space. And right now there are 10 machines that are running within this subnet, within the security group.
So there are 10 machines, but we're basically seeing it on our web page, even though those machines exist and are running on the Amazon. Yeah.
That's a great point. Yeah, so there are resources spinning in AWS's environment somewhere, hopefully here in the US, right? Where we are viewing the the page, reviewing the monitor of those devices. And this is a fully functional Kali Linux machine. This is a fully functional Windows 7 machine. And I can do anything I want with them, or I can use them as offensive and defensive devices to launch and defend against malicious attacks. And we don't collect user information here. We don't want you to rename these with your student name and student numbers. We're not an LEA. We don't want to track student data. So
Okay, so I have the question of what is meant by a sandboxed environment. What this is all representing on this web page here is virtual computers. So instead of having 10 physical computers on a network in a lab, what you have are 10 virtual computers, 5 in this case Linux machines and 5 Windows 7 machines, and it's all accessed through this web page. So these machines are in the cloud, but you're running them as though you're actually logging into and operating an assortment of computers. And this is how students become familiar with networks without having to, yeah, wow, I agree. That's one of the reasons I wanted y'all to see this. And so this is all happening on a web page, but it's emulating a lab, in this case of 10 computers. And that's the sandbox.
When you create an account with cyber.org cyber range, you're going to see names like Cairo LeBlanc and Chico Madere and Demian Gautreau, and you're going to see a nice little fleur-de-lis between the names. So let me tell you real quick. Louisiana, the state of Louisiana put up the funds to build the range. DHS has come on board to scale the range to students across the country. So because it was built in Louisiana, we got to pay homage to Louisiana. So that's why these really great kind of Creole Cajun names are going to be assigned to your students with a fleur-de-lis in the middle.
Nice.
You can use that to send it across the country. So what I said, I've got an activity spun up here in my Kali environment. But when I mentioned that all of these devices are connected, like with the labs you've worked through today, you had 2 microbits and one can talk to the other. As it turns out, my Kali machine can talk to my Windows machine, and Morpheus's Kali's and Windows machines, Cairo's Kali and Windows machines. They're all networked together, so I can discover them on my device.
And I want to add here that when you have a classroom full of microbits, those will be all radio networked together as well.
And maybe attack them. I don't know. I don't want to give any ideas away, but they're part of a network where they can all talk to each other, which is a nice kind of real world example. Oh my gosh, I'm running out of time.
I started you a little late too, so don't worry about that.
All right. So let me tell you what I did. What I did before this activity started was I created a couple of user accounts, and I can see them by typing this command, cat etsy password. And what this will show me, let me maximize for maximum.
So right now he's running a Linux machine and he's in a command line application where he is asking about that Linux machine's password info.
Effect here and run that again. What this shows me down at the bottom, there are 4 users on this account, plus all of these are kind of system tools that are running in the background. But lo and behold, Chuck, Andy, Stephanie, and Ari each have accounts on this user, on this machine. And I can show you how I created those accounts by creating one more account, user add parallax. And now sudo, I have to be a super user, sudo user add parallax. And now if I go up and I take a look at this file again, there are new accounts been added for parallax. So I created Chuck, Andy, Stephanie, and Ari, and I've given each of them a password. So if I go to my /desktop folder, oops, top folder, cd ls, cd desktop, there we go. And I cat my passwords file, txt. What I see down here, Chuck, Andy, Stephanie, and Ari, these are the hashed passwords for each of those users. So they have passwords. I'm not going to tell you what they are. We're going to do a brute force attack. We're going to do a brute force attack and see if we can discover what these passwords are. On the microbits, you had to kind of load the program. You had to work through the various combinations. Obviously, right, things have been done for us in the real world. There are tools out there that hackers are using to break into these passwords. One of the tools is called John the Ripper, and I'm going to use that tool on this passwords file. So I'm going to apply John as the operation on this passwords.txt file. So if you watch while this is happening, in real time, we're going to go through and we're going to try and break some of these passwords. So we're working. And I'm curious, I'm concerned because there should, oh, here we go. Okay, so we've got 5 password hashes. That's not true, there's actually, yeah, 5 password hashes. No, there's 4. I never created one for Parallax, but it's working through now, trying to break those passwords in. Any second now, Chuck's an idiot, right? So his password should break first. Andy's not so smart, so his password should break second. Stephanie's pretty smart. She has, I think, a decent password. But of course, Ari has to, oh, look at that. Stephanie's fell before Andy's did. So my password was password. Obviously, you should never use password as your password. Stephanie's fell relatively quickly because she used a common, what we refer to as a dictionary word, elephant, and that one fell pretty quickly. The root user on this device also has the password. And then I'm going to come back to this in just a second because Andy's is actually a series of 6 digits, which requires a different method of breaking the password. So right now it's working through a dictionary list, right? It's going through and checking all the most common passwords and seeing if I can find a match. Once it finishes that dictionary, it goes into what's referred to as an incremental ASCII attack. And that's when we'll see Andy's password fall. So I'm going to come back here in just a second. I'm going to let that run. So we want to help you get microbits into your classroom. Cyber.org/technology grant. If you go to, there it is, initiatives, you can scroll down to the technology grant space there. And what we'll do is we've got some funds from DHS to put things like cyberbots or microbits into your classroom. So please come on down.
Now that page is currently in revision, so it says basically to come back in the fall and check. But yeah, there are grants that are available for equipping your class with microbits, cyberbot robots, and other goodies. And so this is definitely going to be a worthwhile link to follow. And again, those links are in the slideshow for you.
Here and apply for the current round of funding for technology grants. And the next thing I want to cover is some events that we've got coming up.
And since those are events from 6 months ago, what I'll do is I'll stop the video here and continue on with following that events link to show you what they've got now. So here we are. And so the reason that I think we couldn't have anybody from cyber.org is because they're a little busy this week putting on a boot camp. And then we can look through and there's a whole bunch of topics, including one that's actually an in-person. If you're in the Washington State area, this might be a possibility to you. Then there are lots of virtual workshops. And these are cyber.org workshops. After you've joined, you can apply to attend them by following each of the links. And I'll paste this link into the chat as well. Okay, cyber.org only works with K-12, yes. Does this include college? Okay, so there was a question if it includes college. The answer is no, it's K-12. The answer, another question was, does this apply to Puerto Rico? I would assume so. But you'll have to double check with them. I don't know that off the top of my head for sure, but they can give you a definitive answer there. Also wanted to talk briefly about the cybersecurity standard that was developed by cyber.org. Here's a link to that, and then you can get their PDF. Okay, so you go to their standards page, and then there's a read the standard, and it opens up the PDF. And so this is the first ever cybersecurity standards developed at the national level. And these are also trickling into many state and other standards as well. And so what they have are three subjects: computing systems, digital citizenship, and security. And then they have, yeah, I forgot the nomenclature that they use. I know it's right up front here. So they have, pardon me, three concepts. Those were concepts. And then they have sub-concepts such as information security. And then they break those into topics. And then they break those into graded standards. And so, so here, for example, is the start of networking. And it goes on for quite a ways. There's a lot to read here. I'll paste this link into the chat. The cybersecurity material that we developed at Parallax was before this standard. And I'm actually in the process of going through and saying, okay, how can each standard be implemented with, so this is just a screen capture of a in progress document where I'm taking a look at it. And many of some of the standards are met directly with the microbit. Other standards are basically work pretty well as a lead in to a particular topic, but so the students can basically familiarize themselves through the microbit or cyberbot robot activity. And then there can be additional discussion that's added on top of that. In contrast to what was shown by Chuck, that the high school level cybersecurity course, the 10 to 12 one, where they use the cyber range, which I believe there's a fee for that, a per student fee or a per group of students fee. You'll have to get with cyber.org to find out the details on using the cyber range in your classroom. And again, that he did show the course materials that they have for that as well. Some things I wanted to show you: the Bobot robot. You already saw the keyboard controlled robot, but it's kind of impressive here. That causes some interest in the classroom.
We got a no way. And awesome. Well,
So
it's a good way to show that they are all listening to the same channel. And so that's the difference between an open channel and a encoded channel.
Indeed it is. And we see a dictionary right here as the vehicle by which the information is delivered from the microbit connected to the computer to all those remote cyberbots. Let's see here. Again, I wanted to mention that's part of the Cyberbot tutorial series, which has a microbit plus a separate board with a coprocessor to handle some of the robotic tasks. It's great for reinforcing some of the basics. For example, here is going straight forward and to the right, and you could certainly repeat this straight and then turn to the right, these lines right here, 4 times to create a box. But you can show also how using a for loop for repetitive code to do that and not have to create any additional code. There's some other cool stuff that the Cyberbot robot can do. It has built-in circuit parts, or it has circuit parts that come in the kit. And here's the whiskers, which bumps into things. If anybody remembers the Lego bumper block, with this, they actually get to work with the circuit and code that lives underneath that bumper block to actually detect those physical contacts with objects in front of them. There's also light detection. So the Cyberbot followed the flashlight beam out of the screen as soon as it saw it. Whiskers and bumping into stuff isn't the only way to avoid objects. There are infrared flashlight circuits that you can build to basically allow the robot to see ahead of it And of course, these robots are all running scripts that the students write and modify. And then this was the navigation with a keyboard. These are all chapters in the textbook. So if you're at learn.parallax.com, you can go to the Cyberbot. And then this is the Cyberbot tutorial series. And then what we've been looking at are touch navigation, visible light navigation, infrared light navigation. And then here is the keyboard control. And again, if I open this, we have the chapter contents with 2 activities. Just so you know that this is all documented at the same spot. There's also so this is on a USB connection, this code example, and then this is the one where we're actually using the radio to do it. And then that's the video again. There's also tilt control, which is kind of neat. This one has lots of theory. So we're tilting this microbit, and as you tilt it, you can tilt it away from you to make the Cyberbot go forward, towards you to back it up, and then to the left and the right to make it turn left and right. Here's a new one that we recently did. This is the gripper. So we're using the buttons to control the gripping mechanism. And then the tilt control to drive the robot. We also have some, we're short on time, so I'm going to skip the video, but there are feedback 360, what the heck? The feedback 360 servos are more precise than the servo motors that you see, or that come with the Cyberbot stock. And so keep an eye on the this little marker right here. You'll see that every time it completes a maneuver, that marker is going to be pointing straight down, and that's just showing how we're adding precision to the maneuvers that you write scripts for. These also are faster servos than the ones that come stock from the Cyberbot. But when it turns back, you'll see that the marker's pointing down still, and then when it backs up, it's pointing down again. And then we actually combine the gripper with the feedback 360 servos as an option. Let's see here. This is a little tile of our electronics course. This is how to build circuits. So Chuck mentioned, hey, you can build a voltmeter. Well, yes, and we even have a voltmeter with software so that you can probe different parts of a circuit and measure different voltages. So the voltage is being displayed here. This is what the, and so this is just an animation of what students, to help guide students through taking the measurements as they build these circuits for themselves. There is also an oscilloscope feature. So when we're taking a look at controlling a servo, they're actually learning how the voltage signaling that goes to the servo works by measuring it with a device called an oscilloscope. They're using the same alligator clip connections. And then as they do it, they get to see signals that control a servo as it turns to different positions. Those are just some examples from the electronics course. Lots of good material and theory there. And let's see here. What have we got? Yes, learn.parallax.com. I apologize. We're at 5 o'clock, so I'm going to really breeze through this. These are where the student resources are, but you can hit educators. And when you do, that'll take you to the educators page. And then there's a log in link right there. Okay, I'll take this off screen to do my signing in. Okay, so now that I've signed in, we'll go back to the main page and then select educators. And if we look at the cybersecurity resources, here they are. And I apologize, I didn't show you. Basically, let's see, I'll go to this page in an incognito window to show you what you would see if you're on that page without being logged in. See, it says educator only access down here. And then when you log in, it instead gives you a link to the assessment material. And so here we have assessments for the different things. So we'll look at encryption intro. And we'll go ahead and open up the, let's see here. So this gave us 2 different types of documents. I'll open up, oh, it won't let me do it because it's in a zip. Just a second. So first of all, I'll copy these and then put them in my downloads, or which is essentially unzipping it. Paste. And where did they go? Okay, let me unzip it into a folder. Let's see here. More options.
We have the question for those who can't stay, or you are going to be sending links to these resources.
Yeah, well, the links are part of the links are in the slideshow. And then of course you'll have a recording for those of you who have to leave immediately at 5 o'clock. I apologize for going late. I kind of stumbled on a few demonstrations. So yes, you'll have a recording. You can just kind of open it in YouTube and go to the end and see that. And then of course the slideshow is there for you as well.
There's a question here from Maureen. I'm finding that I need to tweak a lot of these activities for my middle schoolers. Will that be more so for the Cyberbot?
Less so for the Cyberbot, probably. The Cyberbot is kind of the between the intro to writing scripts and the cybersecurity material. We also are tweaking it for middle school level and working to align it to the cybersecurity standard. Let's see, do I have so the last thing I'd like to show you is where to get microbits and Cyberbot robots. Basically you can go to www.parallax.com. We are a microbit channel partner. And there's along the left, you can hit shop and then go to the left, and there's the microbit category. And I'll paste this right into you. And then here is a slide with our support, how to contact us info for sales, educator hotline in case you're stuck and or just about to start class. It's a good one to call. We have our education email. This is definitely recommended for reaching out to us. That's the email that has been sent to for all the workshop emails as well. Then we have our sales line and email, and then forums for discussion. Cyber.org sends their thank you for attending this, and we thank you too. I appreciate it a lot, folks, and please do reach out to me if you have any questions, comments, and we can reconvene next week on any topics you want to go further into. Okay, so that brings the recorded portion of our workshop to a close. And thanks again for coming. And like I said, reach out to us if there's anything we can help you with.